Either one or the other.
It's between 17 and 48.
Or right. But why do we put an or here? That's the question.
There are two ways.
There are two ways to get there. Okay, so that means if we come here from one way, we are guaranteed that x is greater than or equal to 17. If I come from the other way, we're guaranteed that x is less than 49. Right? Because that's the whole nature of merging the two branches of a conditional statement. So the next thing you have to do is to reverse this back and say, okay, first of all, you look at 35, and then you say, okay, does x equal to 35 satisfy this requirement? Yes. So that means we could have taken that branch. The next question now is, does x equal to 35 satisfy this requirement? X is less than 49.
No.
The answer is yes, 35 is less than 49, so it also satisfies this requirement, which means I could have come from the other branch as well. Yes?
Use the now, please.
Oh, this means I should have implemented my Wiimote pointer thing, so that way I can just go there and keep pointing around. Okay, so let me just say that again. I usually cannot remember what I just said about a few minutes ago or a few seconds ago. Okay, so in this case, this is the post condition just by knowing nothing about pre-16, which is basically it makes this statement the most general statement you can ever make, because we did not make any assumptions whatsoever to begin with. But out of this statement, the or means that we are merging from two different branches. If I come from one branch, x is guaranteed to be greater than or equal to 17. If I come from the other branch, x is guaranteed to be less than 49. Okay, that's basically what it's saying. If you combine these two statements, it really is not saying much, is it? I mean, x is greater than or equal to 17 will cover one part of the number line. X is less than 49 covers the other part of the number line. But when you overlap those two, it is the entire number line. So by itself, this is not really telling you much other than almost exactly like true. But when we look at this, analytically, it means that when we come from one side, I keep using my finger, Danny. When we come from one branch, we are guaranteed this. If we come from the other branch, we're guaranteed that. So the next thing you have to do, okay, let me just write it down here, since I'm also recording the audio portion, but that we want to have a triple record of what we just said today. So people have no excuses of saying, well, but I haven't seen this before. Trust me, that will happen next Friday. It will happen because not everybody is here. All right, so what we're going to do is to say, okay, so if we come from one branch, x greater than 17 is guaranteed. If we come from the other branch, then x is less than 49 is also guaranteed. Okay? So then the first question is, does x equal to 35, is x equals to 35 compatible with these two conditions?
Yes.
Okay? The answer is yes. Okay? X equals to 35 does not conflict with either conditions of the disjunction of post 18. Is that making any sense? So this means that we could have come from either branch of the conditional statement. Is that making sense so far? Okay. If I can be coming from either branch of the conditional statement, that means when I work my way back, I have to work my way back through both branches. Okay? Okay? This means that we have to work our way back through both branches. Okay? And remind me again, what are the two branches that would get me to line 18?
X less than or greater than 17.
Okay, so one branch is when x is less than 17 on line 16, goes through line 17, and eventually merging on line 18. That's one way. What is the other way? The other branch is when x is greater than or 17 to begin with on line 18, or excuse me, on line 16, skips line 17 and merge on line 18. Right? Those are the two possible ways to get here now that we know that x equals to 35 does not conflict with either of the conditions. Well, how is that helping me? Okay, well, let's start with this one. This is the easier one. If we go through line 17 and x ends up to be 35, how do we work our way back? Okay, in other words, if we know that post 17 is x equals to x 35, what is pre-17? Hmm?
Well, you prove post 18.
You don't even go.
Sorry?
Inverse function of the y.
No, not inverse. This one is actually not using the inverse. Okay, the formal way of doing this is to basically.
Do you forget it?
Nope, you don't forget. Okay, so this is something that we have touched on last week already, but I never really quite treat it in a formal way. But this is the formal treatment of something like this. Okay, so what we do is we start with the post condition. We want to reverse it back to the precondition. That's what we are trying to do. So the question is, how do we start with a post condition and reverse it back to the precondition, knowing the statement already, because we already know what line 17 looks like. Okay, so we do have all the pieces. We do have all the pieces to do this. Okay, what do you think? Okay, first of all, we know that the right-hand side of line 17 is reversible. We have established that a little bit earlier. Is that good? Right? Okay. So that means we can also walk backwards. Okay? Instead of walking forward, we can also walk backward. Now, everybody already knows the answer. Everybody in this class at this point should already know that if I know that post 17 is x equals to 35, and line 17 is just adding 32 to x, then before line 17, x has to have a value of 3. Is that right? Okay, it's just intuitive. But what I want to do is to push that one step further and just say that in general, okay, if I give you the right-hand side of line 17 to be reversible, how do you figure out what the value of x is before that line? Because I want to make it as general as possible. Yes?
You just substitute x for 35 to the left-hand side?
That will work. Yes. Yes, but it's not a step-by-step process, back to the precondition of line 17. So what we want to do is to do it like this. In this case, we say the precondition of line 17 is also based on the substitution. But this time it's based on the substitution of post 17, which is reversing what we are doing usually.